Good morning, Algebra 2. Today we are going to be talking about our very last unit or section in this unit, which is 11.8, solving all polynomial equations. And the first thing we need to talk about is the number of roots in a polynomial equation theorem. And it says every polynomial equation of degree n has exactly n roots, provided that multiplicities of multiple roots are counted. So essentially what that means is whatever your degree is how many roots you're going to have. And we kind of did touch on this in the beginning of the unit here, but today we're going to actually talk about it in depth. So let's just say, for example, you had x squared minus 2x plus 1 or something. That would mean that this guy is going to have 2 roots or solutions. Okay? Let's say you had something, 3x to the 17th power minus 5x to the 4th power plus 3x squared minus 7. Well, since the highest exponent here is 17, this guy would have 17 solutions, which is pretty crazy. We won't ever deal with ones really that big, but you could get there, and you should have 17 solutions. All right. So also, just as an FYI, if you use the word roots, that's the same thing as solutions, which is the same thing as x-intercepts, which is the same thing as zeros. Okay? So if I use any of these 4 words, or, obviously the word answer, which is, you guys know that's synonymous with solutions, they all mean the same thing. You're finding your answer here. So make sure you write all these down. You know that they're all really the same thing, because I would be using them interchangeably, and you would need to know, oh, she really wants me to just find the answer here. Okay? Okay, so example 1 says find all the solutions of the factored polynomial. So what we're going to use here is called the zero product property. Which it's kind of simple when you think about it. You used it in Algebra 1, and it basically just says, like, let's take, for example, if you had 15 times something equaling 0, you knew it was equal to 0. Well, what's the only number you could put in here to make 15 times something to be 0? Well, if I put a 1 in here, 15 times 1 is 15. That's not going to work. If I put a 2, it's going to be 30. The only thing that'll get this to 0 is 0 itself. And you could do it the other way, too. What times 15 gives you 0? Well, this would still have to be 0. So basically, if you have a bunch of things multiplied together, or just 2, you could have 3 things. Let's say we had 15 times 16 times what gives me 0. The 0 would be the only thing to cancel it all out. So if we have a bunch of stuff equal to 0, well, they could each be 0 themselves. Look, we have the second thing here, the first thing here, the last thing here. We could have it as the middle thing. So 15 times 0 times 16 would still give me 0. So essentially, one of them's got to be 0. So what that means for us, it's actually a very strong property to have, because if you factor something out, like for instance, 3x squared times the quantity x minus 5 times the quantity 2x plus 3, this is already in factored form. And you actually want to leave it that way. Leave it. A lot of people are very tempted to multiply all this out, but that would actually make your life harder, because by leaving it as the factored form, you already are set up to set each thing. Here's our first thing, here's our second thing, and here's our third thing. Each thing set equal to 0 itself, because one of them's got to be 0, as shown over here. I have to have 0 to get me to 0 here. And since this all equals 0, one of these things has got to be 0. And we don't know which, so we have to do them all. So essentially what this means to do is to take 3x squared and set it to 0 itself. 3x squared equals 0. Then we have x minus 5 equaling 0. And then our third thing is 2x plus 3 equaling 0. Okay, so now we have 3 separate linear, well, this one's quadratic, but 3 separate equations that we can now go ahead and solve. So solving this first guy, we'd have to divide by 3 on each side, and we'd have x squared equals, well, 0 divided by 3 is 0. Square rooting both sides, we'd have x equals, well, square root of 0 is 0. So there's one solution. Here, I would just have to add 5 to get x by itself. So I would just have x equals, well, 0 plus 5 is 5. And then we're done there. Here, I just have to subtract 3 on each side. I get 2x equals 0 minus 3 is negative 3. We divide each side by 2. And we get x equals negative 3 halves. So we actually have 3 solutions to this equation. So I kind of ran out of room. I'll just write them above it. So x equals, and I always put these in least to greatest order, so this guy is negative, so negative 3 halves, and then 0 would come next, and then 5. So those are our 3 solutions to this equation. Okay? And you might already be thinking to yourself, well, if I did FOIL this out or multiply everything through, this term here would give me an x squared multiplied by this x squared, so the degree of this actual polynomial is 4. So you might be thinking to yourself, why don't I have 4 solutions? I don't understand. I thought you just said however many my degree is however many solutions I'm going to have. Now, you do technically have 4 solutions in here. And let me show you where your fourth came from. These two, when we were solving both of these, those were normal equations. Now over here, we had to use this very special guy, the square root. And if you remember from forever ago, and I always used to yell at you guys, plus, minus, plus, minus, plus, minus. If we did like the square root of 64, it'd be plus minus 8 when we were solving things. So technically, you have plus or minus 0 here. Now, we don't write plus or minus 0 because, well, plus 0 and minus 0 are one and the same thing because 0 is just 0. So there's technically 4 solutions here. We have negative 3 halves, negative 0, 0, and 5, which is kind of silly to say, so we just say it is 0 here. Okay? You can kind of think of it as it could have up to the degree of equations. It could have that many solutions up to that degree. Couldn't have 5, but it could have 4 or less. Okay? So letter B here, kind of the same idea. It's already factored, so leave it like that. You're just going to break each piece. We have 3 different pieces here. So break them all apart. So we have 2x minus 5 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Solving this first guy, we add 5 to both sides. We get 2x equals 5. We divide each side by 2. We get x equals 5 halves. And we subtract 1 from each side here. X equals negative 1. We add 1 to each side here. So x equals positive 1. So writing our equation out, we would have a negatives first, so x equals negative 1. And then between 1 and 5 halves, 1 is smaller, and then we have positive 5 halves. If you wanted to, you could write this as x equals plus or minus 1, comma 5 halves. Either of these would work. Okay? And again, we got 3 solutions. Because if I multiplied x times x times x, that would be x cubed, so we actually do get 3 solutions. Truly 3 real solutions here. Okay? Now, it is no mistake that essentially your signs, this negative 1 came from this middle term right here, so that's just going to be the opposite of what you have. And here it was a negative 1, so we got positive 1 out of it. Here it was a negative, we got a positive answer out of it. Now here's a little tricky because we had a coefficient on our x, so we had to put 5 over 2. It's always the last thing over the first thing. You want to solve these a little quicker. Now you're going to see a lot of patterns with these, so if you do, take advantage of them because they will make your life easier. I have a couple more examples to show you, so I certainly hope you join me for the next video.